Maybe going away. Cool. So take a look. Super quick. These we'll fly through because we definitely did these already. What do you want me to do? You want me to menu go back? So one last chance. Anything on that first page? Folks at home, questions? Even D&E. So I put the work there on the side for the tangent, so you knew where the negative radical 3 comes from, which you can always do. You do not have to bury like a bunch of work right in the problem if you're like going through this a little bit more complicated kind of evaluation. So again, I just went to the unit circle and I just went to 5 pi over 3 and went from there. Yeah, Peyton. Yes, yes. Thank you. Negative 5 over 2. Let me fix that. Yeah, so E, right? Yeah. Negative 5 over 2 there for E. Thank you, thank you, thank you. That's what happens when I multitask. But good catch, thank you. Could have been, yeah, that would have been fine. But I didn't. Hey, good. Turn the page. Silly me. That's why even your teacher does his math in pencil. Good. F, G, and H. Well, we'll scroll to see the rest of H, but there's F and G. Again, I think we did these in class, but just so you can see them, talk through them, ask questions, because I have just more practice for you, and I'm going to let you do this on your own more than with me. So there's F and G. Let's get closer. Scoot, scoot, scoot. H we definitely did, right? I just wrote it out again. But I know that sometimes I go a little fast, or sometimes you don't get a chance to write it all down, and then you get stuck. I care more about the process than the actual answer being right. So if you can understand it, that'll give you a good chance. Good? Brady, you good back there, brother? Okay. I was just a slightly more complicated version of that because it just took some factoring. And so like my whole, like steps 3, 4, and 5 there, if you're counting them, is just all factoring up top. Again, leave the denominator factored so we can divide stuff away. Careful with like parentheses and square roots and just making sure you close parentheses if you open them and your fraction bar goes all the way across. Like silly little things like that. I would hate to have that cost you. Again, these are up on Canvas, so we don't have to go through them one by one if you get a hang of it. J is probably not something I would put on a quiz or a test, but it's just good practice. And there's more practice like that in what you'll see, but like today, tomorrow, for sure. But we just end up, again, we just get this 2 over 0, so it doesn't exist. Which we probably could have figured out by just saying, okay, like what if I plug in 0 right now from the very beginning? So I get 1/2 plus undefined, right? The only way for a function to be undefined but still have a limit is there's got to be a hole there. And having undefined and not 0 over 0, that's a pretty good indication that we are going to run into an asymptote there and not anything else. So like right here, right? You plug in 0 right there, 0 right there, 0 right there. You get this undefined part with that 1 over x. Not 0 over 0 if there's an undefined number in there. So there's K and L and M. Why not? Well, might be able to sneak a peek. But again, I just did a little side work off on the side to work through that factoring. And I showed you that quick little shortcut yesterday. I don't know, because you guys were home. Did you catch that? Did you see that? It's a really, really, really nice, fast way to factor when A is bigger than 1 or just different than 1. You set it up, well, diamond problem or blanks or however you want to think about adding to 7 and multiplying to 6. You still set it up, x plus 6, x plus 1, but you just take A and divide it. Like I just take the numbers, It's a super like nice like way to avoid factoring by grouping. It's happening in the background. It's still happening. We just do it in a sneaky way. I've worked through the process in the back of my mind. The front of my mind still doesn't quite get it, but it still works. You take your numbers, whatever they were, right? Drop them in. And I know that that's not the answer, right? X plus 6, X plus 1 is not going to multiply out to this. So I get the 3 involved. And if I divide my numbers by whatever A is, I check them and see what happens. If it goes in perfectly, nice whole number, sweet, done. I'm just going to divide it. X plus 6, no. X plus 2, because 6 over 3 is 2. If it does not go in evenly, I make sure the fraction's simplified, and then I take the denominator and I move it in front, and it becomes the coefficient. I have done it, because I'm like teaching quadratics and algebra 2 right now, I have done that probably 100 times so far, and it just keeps working. So I'm just going to go with it. It works really well. And while factoring was nice, because we were able to divide away the x plus 2's, I still end up getting 0 in the denominator if I plug it in. But it just gives me a simpler function to plug it back into. So we're always going to factor and simplify, because it makes that kind of that next process just a little bit easier. And so what I think would be better than what I did yesterday is that, again, I kind of came like down or off the side, like I did some separate side work to plug in a number to the right of 2. It's a one-sided limit at an asymptote. Plug in 2, 7 over 0, right? That's going to be an asymptote, so I want to know where it's headed, infinity or negative infinity. So I plugged in a number to the right of 2, which is 2.1. I got 73. That's heading towards infinity. So that's kind of just how I wrote these last 3 problems. Is I thought about plugging in a number, but I know I'm going to get something over 0, right? The first one was 7 over 0. This looks like 11 over 0 for both of these. And so I plugged in a number to the right for L, number to the left for M. Got a big positive number, so positive infinity. Got a big negative number, so negative infinity. Cool. Okay, sweet. Folks at home, questions? Okay, awesome. So what I want to do today, I just want to look back at this so I don't forget all the things I had to say. So there are the solutions to homework 1.3. So if you're looking at your cohort on the announcement today for Canvas, I put up what your homework is that you can get started on in class and just finish tomorrow if you need to. So it's just write in your guided notes. But what you'll see is that I'm helping us skip some of the ones that we don't really need to look at right now. So just like turn the page, we just finished page 28. You just go to page 29 through 31, and it's just more of the same kind of practice, but I want to let you do it without me. But you can skip if you want. And so if you want to mark these down now so you don't have to look back at this, feel free to skip those 4 problems. Now, some of those include like the complex fraction. I think there's 2 of those. It was like 10 and 18, I think, off the top of my head. Do them if you want. All right, feel free to do any of those if you want the extra practice. Let me make sure I got the thing right in front of me. Let me stand in front of the camera so you guys can really see me. Yeah, 10 complex fraction, 18 complex fraction, you can do that. 13 and 19 were just piecewise, so we can skip those for now. Okay, so those, you know, handful or 2 of problems, just practice to get us ready. Why? Because, back it up. All right. What I have for you is copies of practice quizzes that you can work on as much or as little as you want. Okay. I'm not going to be collecting those practice quizzes. So you guys in front of me right now, I'm going to hand them to you. Everybody at home, you can get those tomorrow, but the PDF of chapter 1 is sitting right there. It's just pages 41 through 48. They're all there. But I will tell you which ones to skip. Some piecewise stuff and things like that. We don't have to worry too much about. Okay. So here's the plan for the next couple days. Homework 1.4, just some practice with the same kind of stuff. Those 3 pages right there. Skip those 4 problems if you want. Then decide how much practice you need beyond that. If you want to go back to some of the graph stuff, Absolutely. Good idea. There's some good practice in there. What'll happen probably by like Thursday night or Friday at some point, as soon as I can, for sure, I will get the real quiz out to you. Okay. And what the real quiz will look like is kind of like that last test that we took. Even the last quiz that was optional, where I send it out to you, right? And you just take it online, but you supplement it with whatever handwritten work you need to. Because some of them are going to be like, look at this graph, what's the limit? And you just pick the right number, right? So I don't need to see work for that. But some of them, not questions like those, but questions like we've been working on, you obviously have to show your work to do that. So it'll just be visible to you, and you just handwrite and upload whatever you need to Canvas. Laura. Sunday before midnight. So start it whatever you want. Finish it before Sunday at midnight. So you can take breaks. You can go back to it for sure. It won't be long. There won't be 30 problems or anything crazy like that. So I would love to keep it like under an hour. It's just a quiz. But I do want to like look at some graphs and draw some graphs and kind of show you the different styles of questions too. And you're going to see those on the practice quiz. The AP style calculus questions are just a little bit different, right? They've got like different kinds of multiple choice and different kind of fill in the blanks, and like you have to draw some graphs yourself. So I just kind of want to get used to seeing those. And there's going to, like I said, there's going to be some questions on the practice quiz to skip. And I'll just make sure that I let you know exactly what those are. Okay. So what I want to do today, for those of you guys in front of me right now, is give you one or both of the following. We'll start with this one. Does anybody need or want a hard copy of that 4-page trig cheat sheet? Just so you have a handy copy. It's all online. Always has been, always will be. Literally just Google trig cheat sheet. I think it's the first one. Cohort B, you guys can pick one up tomorrow. And then for everybody, these are the practice quizzes that are optional, that I will post the answers to, and I will tell you which ones to skip, but I'll probably do that like this afternoon or sometime tonight. So don't get too far into this one and then be like, I don't know how to do this. It's because we haven't done it. You can just skip it. Okay, so what I would love to have happen is you just start knocking out homework 1.4 on your own. These problems right there, okay, pages 29 through 31, and you can skip those. What I'm going to hopefully do for those of us at home is I want to like work through the solutions in real time on paper by going like, if I can do it, like pointing down at my, yeah, that might work, pointing down at my desk so you can see it. And I'm going to do the same. I'm going to jump on to this meet separately here. So you guys can watch me do. Turn that off. Don't need that. Yeah. Josh, there we go. Cool. So just a nice, relaxing work day. I'm going to put on some tunage, something relaxing to listen to. Feel free to listen to some music on your own. Cohort B, if you guys want to head out, great, you can. If you want to stick around and watch some of this work happen, we can do that. I will post the solutions to these on Friday since it's due Thursday. But feel free to stick around and work with me. So I liked this one. I was listening to this in my Algebra 2 yesterday. So just some, oh, I love this song. Why is it always Grammarly? Every time. Always Grammarly. Let's see if I can. So folks at home, just give me a shout if you need anything. Now I have to find my copy. There it is. Let's see, is it upside down? It is. And it doesn't even look very good. It looks pretty blurry. Is that blurry to you guys at home? Okay. All right. New plan. It's like it's just too close. Sorry if this makes you nauseous. Don't look at the screen until I do it. I didn't know if this was going to work because I don't have a doc cam. And I don't think the school has very many anyway. Well, do your thing. Don't worry about me then. I will just sit here and you can ask me questions and then I will point it at it. How about that? You can just look at my face. There's my pencil. Cool. This is weird. It's like Inception. I got Xyla to smile, so that's good. Oh, what's Here's what I'll do. I got an idea. I'll at least write the answer up here once I get one. We'll do that. Let's see. Big thing for number 2, I don't like the way that it's written without the parentheses around it. Please draw these in. I think that is more correct. Because now I know I got to take the limit of everything. If you need some guidance on number 6, let me know once you get there. Okay, I'll put the next 4 answers. Sure. Number 6. Okay. So, what do you think? Number 6. Can we just plug in 0 right now? Why not? Yeah, because I can't divide by 0, right? And so if I plug in my number right now, I definitely get 0 on bottom. So I know it's undefined. And if a function is undefined at a spot, then I can't just use direct substitution. But I hope that there's a hole there and not an asymptote. And so I think about, okay, well, what kind of undefined number do I get? Well, let me plug it in up top too. Just kind of in my mind, I think about what that's going to do. Okay, so 4, so 16. 16 minus 16, 0. Nice. Okay, so 0 over 0. So I feel pretty good about being able to find this limit algebraically. But it's not that it's like, it looks like 8 with like a can factor, because this doesn't have parentheses, but this one already does. And so another option for evaluating limits to try to make things simplify is to expand it out. Take x plus 4 and multiply it by itself. Like actually square it and get rid of parentheses in that process. Now I'm going to use Pascal's triangle to help me do that. Now you could sit there and just do x plus 4 times x plus 4 and double distribute and drive yourself crazy. But this is always going to work out that if it's, let me use the space over here so you can see it. If it's a plus b squared, it's always going to be 1, Pascal's triangle, a squared, b to the 0, plus 2, a to the first, b to the first, plus 1, a to the 0, b squared. Like that's the expansion of that binomial from the binomial expansion. And so if I do that, okay, I'm going to expand. I mean, and obviously this is way more complicated than it needs to be. It's really just a squared plus 2ab plus b squared. That's how we get there. Just like, you know, lots of things kind of connect through Pascal's triangle. And you're going to see, I'm actually working on it right now. When you get to number 11, we're going to go one more step in Pascal's triangle because we have to cube something. That just goes a little bit faster that way. So x squared plus 2 times x times 4, so plus 8x, plus 4 squared, so plus 16. So what's circled in blue up top is what's written in blue so far. Now, nope, I want to get rid of parentheses so I can put stuff together. Now, I don't want to forget about that minus 16, so that minus 16 is right there. So being able to expand might actually help us make things a little bit simpler. What do you see? Do you see anything in there? Yeah, all right, there's 0, all right, plus 16 minus 16. So all we have left is x squared plus 8x over x. Okay, now what? I know where my problem is, and it's right here. And if I know that ahead of time that I'm going to get 0 over 0, then there should be a way for me to get an x factored from the top and the bottom so I can divide it away. And that happens right now. Factor out that GCF of x and divide it away. Switch colors. So we get the limit as x approaches 0 of, all right, so those x's are gone, of just x plus 8. I removed the problem, so now I can plug in 0 and get 8. So expansion is another nice tool. Factoring, rationalizing, and expansion. 5, sure, absolutely. 5's a nasty one just because, gosh, this tangent is just rough because you have like this rational function you have to deal with the whole time. And now they want me to take this weird theta value of pi over 6 and square it and not do anything else with it. Like there's no trig with that theta squared part. It's just, okay, square theta. But like plugging in pi over 6 is not an issue at tangent, right? Tangent's vertical asymptotes happen at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, multiples of pi over 2. So I'm okay with just jumping in and just dropping in pi over 6. Pi over 6 squared times the tangent of, sorry, that's a pi. Make it nice. Pi over 6. And it's really just that tangent of pi over 6 that's going to cause me any trouble. So I'm just going to come off on the side and do that part so I can see what kind of answer I get. Because if you plug that in, now here's the thing with tangent or secant or cosecant or any of them. I mean, you can always plug it in a calculator and save yourself the trouble if it is 1/2 or 0 or 1, right? But you plug in that, it's not, right? You get point something, yeah, 0.577, maybe something like that. So what is tangent of pi over 6? Yeah, it's y over x, right? Sine over cosine at that spot. So sine is 1/2, cosine is radical 3 over 2. And so I just have to evaluate that and simplify it. So I get rid of the 2's, same denominator from my complex fraction, so I can get rid of that. So 1 over radical 3, and then rationalize. I like to. You don't really have to, but I think it's just going to look a little nicer. So I'm going to call it radical 3 over 3. And now I can use that. So that was just a little bit of side work to help me get to here. Okay, so I got to square pi over 6. So pi squared over 6 squared. Okay, so 36 times radical 3 over 3. Again, you don't have to rationalize. You could call that 1 over radical 3 right there, and the square root would just stay on the bottom. That's fine. It actually keeps your numbers a little bit smaller. But then you just multiply straight across. So pi squared radical 3 over 108. Or, again, this is a completely viable option. Like just stop right here with tangent and call it 1 over radical 3 and get a slightly smaller set of numbers that gives you the exact same answer. So either one's good. Calculus, we can leave denominators irrational. Okay. So yeah, either one, the red one or the blue one, both great answers. And the thing about the AP test that you take next year, if that's a plan for you, if this is a free response question, if this is an FRQ, they'll take either one. They'll accept both. But if it's a multiple choice, only one of those answers is going to be there. And if you don't rationalize and it's the red answer, you don't get there. Or if you go too far and you do rationalize the denominator, then the blue answer is going to be the one that we're looking for. Then, so you have to kind of like almost pause for a second and look at the answer and decide, okay, should I rationalize it right now? Because my answer has a rational denominator, or is it irrational? And I'll make my life a little bit easier and do just one less step of work. I don't know. They're both really nice. But just looking at it, I kind of like the blue one better. The numbers are smaller. I don't have to deal with big numbers. A little gross that the square root's on the bottom, but I start to care less and less about that because it's still true. It's perfect. It's good. Just work. Yeah, of course.
How we doing, folks at home? We doing all right? Sweet. Okay, good.
What about 7? It's basically if you plug in 1, you get 0 over 0.
Right. So you're going to want to, for number 7, you're going to want to factor that denominator. So, because you got the quadratic, and it's a difference of 2 squares, so you can do x plus 1, x minus 1, and then it'll cancel out, at least the x minus 1. So then you can just plug in 1.
What is this?
That's the practice.
So that's, yeah, that you can do, like, if you want to get a little more practice going back to some of the graphs, seeing kind of the style of questions that I'm going to ask, because I want to ask them in the AP style, just so you can kind of get used to seeing that. So I'm going to model our quiz after those 2 practice quizzes. Put up some answers. Eleven and 12 are tricky, just a lot of algebra in there. So I'm going to make some space. 9 and 10, we'll go here.
Wait, which ones are you able to skip, like 10?
So yeah, you can skip 10, 13, 18, and 19. I'll do them. 10, 13, 18, 19. Any of the complex fractions and any of the piecewise ones. Twelve is just a weird one because h is going to 0, but there's still an x in the problem, so there's still an x in your answer. I think we might be out of here in 5 seconds because it's a shorter day. Right?
Forgot about that.
Yeah. So we've got some homeroom after 4, so don't forget to head to that. Cohort A and cohort B, of course, we'll do that virtually. I will put up the solutions, the corrected ones with a 5/2. Nice, thank you, Peyton. So that you got all the right work, but everything else I think looks good. And then these 3 pages are not due until tomorrow, okay? So cohort A, you guys in front of me, you can just work on these tomorrow. Just log on for attendance and then stay on if you want or hop off, that's cool. Cohort B will just finish it up in class. So don't feel like you have to get all of them done right now, but know that you'll only have the 45 or 50 minutes or so to get that done once we get there. Cool. Any questions? I'll hook you guys up with copies of the practice quizzes and the trig cheat sheet tomorrow. Okay. See ya. Bye, everybody. See ya. You're welcome. Come on in. Yeah, how you doing?
Pretty good.
Yeah? That's good.
Thank you.
Welcome,
There she is. Look at this. So safe. I was supposed to take her back, but I forgot I couldn't take her. Let me go. Hi, Steve. Hi, you can see what you're
Yeah.
Hi, you can see what you're
What's up, Trent? Here, let me move those things, Macy, so you can get back there.
Okay.
Because we gotta sit in the same seats. I gotta make sure that I have the seating chart correct too, so I'm not sure put that up on the board. What's up, Steven? How we doing?
Good, how are you?
Good. Let's see if I got it right. Let me log off like 50 things first.
What's wrong, baby?
Oh, no battery, don't do it. Don't die. Come back. There we go.